I am Abhiraj Singh from Section 5, Subgroup 3. My roll number is 20MI33003. For the task, I will be using this motor shield to perform the task. The L298 driver is connected to two motors, one at channel A and the other at channel B. For the task, I will be using output 1, out 2, IN1, IN2, and ENA, that is enabled A pin. ENA is connected to the IO4 here, and this IO4 is connected to IO6 here. IN1 is connected to IO12 and IN2 is connected to the logic gate XNOR. In XNOR gate, when both inputs are same, it gives output as 1. That is, when both inputs are 1, 1 or 0, 0, then output is 1. And if it is 1, 0 or 0, 1, then output is 0. With this break and DRA direction A and IO12 PWMA, we can control speed and direction of the motor of channel A. For calculating speed, we are using this formula. This 255 came as this is the maximum value that PWM can take. Here I have initialized a variable PWM and assigned a value 200 to it. In the void loop, the 12th pin is connected to IN1 and the pin 12 decides the direction of rotation of motor. That is, if the output is 1, then motor will rotate clockwise, and if it is 0, then it will rotate anti-clockwise. Here 8th pin is set as output of brake, and here I have kept the low to disable the brake. The pin 4 is connected to the ENA and the pin 4 is connected to the pin 6, that is PWM pin on the Arduino. Here analog write will generate a PWM signal. The first parameter here is the pin number 6 and the PWM is basically the variable assigned, that is the value of the variable. To calculate the value of the average voltage, we can use this formula. That is, if the value of the variable is 200, then it is 200 divided by 255 multiplied by 5. Now in schematic capture, while running the simulation, it takes some time for the rotating motor to get to a stabilized value. Now the motor is rotating with a stable value of plus 35. Now I have reduced the PWM variable to half, that is 100, and now will again run the simulation. Ideally the value should have been half, but here it is 9.27 as it is not an ideal motor and is not a closed loop. Now for the node-RED task, first I went to the dashboard, then I selected the slider, that is here, and then I selected the gauge, that is here. For the slider, I went to the edit and then edit group and then edit tab and then edited the group as water level and then labeled it as water level controller and specified the range from 0 to 100 with step 1. Then for the gauge, I put the group as water level, label as water level in centimeter, range from 0 to 100, and then specified color gradients with ranges, that is from 0 to 30 green, 30 to 60 yellow, and the rest, that is 60 to 100, it is red. And then join both of them via wire. And then I selected a new slider, that is here, and then a chart. For the slider, I labeled it as gas pressure controller with range from 0 to 40. And for the chart, I labeled it as gas pressure in bars, type of chart as bar chart, and range, that is maximum value 40. Then I clicked on deploy, and then to see what we have created, we need to go to the server address, that is 127.0.0.1 colon 1880 backslash UI. Here UI means user interface. And now here, as we move the slider, for 0 to 30 it is green, and then beyond 30 like till 60 it is yellow, and for rest of it is red. And similarly for pressure bar, as we move the slider, the graph changes. Now to connect the mobile to the node server, I went to the control panel, and then network and internet, and then view network status and tasks, and then details, and here is the IPv4 address, that is 192. So for connecting the mobile, we have to type in mobile in Chrome, that is 192.168.1.101 colon 1880 backslash UI. Now, as we change the water level controller in the system, it gets changed in mobile also. Similarly for the gas pressure control. And now when we change the value in mobile, it gets changed in the screen also. Thank you and have a nice day ahead.